In this video, I'm going to show some examples of word problems that involve multiplying decimals. Question 1 says Adam pours 1 1/10 ounces of cereal into a bowl. Each ounce of cereal contains 1 8/10 grams of sugar. How many grams of sugar are in the cereal in the bowl? So I have 1.1 groups of 1.8. That is 1.1 times 1.8. And then I'm going to go ahead and write out how many places I'm going to need to shift my digits when I'm done with this problem. And I see in each one of my factors, I see one digit behind the decimal. So a total of 2 digits that I'm going to need to shift when I'm done. And now I can just multiply this as 11 times 18. So that would be 88, and then a 1 and a 1. So 198. I'm going to shift the decimal over 2 place values, 1, 2, and I have 1.98 grams of sugar, which is choice A. Very quickly to remind you why we're shifting place value digits here, when I'm multiplying 1.1 times 1.8, this is really 11 tenths times 18 tenths. 11 tenths is 1 1/10, 18 tenths is 1 8/10. So I'm really doing 11 times 18, which is what I did just right up here. And then I am dividing that answer by 100. That's 2 powers of 10. And when I divide by a power of 10, I shift digits to the right because our place value system is based on the number 10. Question 2, 1 pound of the potting soil Matt uses has a volume of 2,700 cubic feet. He puts 3 9600 pounds of potting soil into a pot. What is the volume of the soil in the pot? I'm going to take the factor that has the most digits, which is 3 9600 pounds, and I'm going to multiply that by 2,700 cubic feet in each pound. Before I multiply this out, I'm going to count up how many place values I'm going to need to shift my digits when I'm done. So I see 1, 2, 3, 4 digits behind the decimal that represent fractions. So that's going to be 4 place values that I'm going to shift when I'm done multiplying. Now my problem becomes 396 times 27, and I can just go ahead and multiply. 6 times 7 is 42. It'll be 67. 21 and 6 is 27. 19 and then a 7. So we have the digits 10692, but I need to shift them over 4 places to the right. So 1, 2, 3, 4. So we now get 1 and 692 10,000ths. And you may notice that that doesn't match up with any of our answer choices. That's because they rounded the answer to the nearest thousandth of a cubic foot. So our answer is 1 69 thousandths cubic feet. Question 3 says pure gold is too soft to use for making jewelry. A jeweler uses a gold alloy to make rings. Each gram of the alloy contains 917 thousandths gram of pure gold. How much pure gold is in 3 6400 grams of the gold alloy? We are going to want to multiply these numbers because we have 3.64 groups of 0.917. I want to put the number, the factor that has more digits on top if I'm doing traditional multiplication, and then line everything up on the right hand side. Now technically in this problem I really didn't need to because I'm not going to do anything with that 0 there. And now I need to figure out how many places I'm going to shift when I'm done. So I have 1, 2, 3, 4, 5 digits behind the decimal that represent the fraction denominator that I'm going to divide by. So that's 5 place values. And my problem is now 917 times 364. Now this is just a regular multiplication problem. So go ahead and multiply this out. 6 times 7 is 42. That would be 10, 55. When you go to the third digit, make sure you put 2 zeros to hold your place value. 3 times 7 is 21. 3 and 2 is 5, and 3 times 9 is 27. Add everything up. And I have 3, 3, 3, 7, 8, 8. But I need to shift this 5 places to the right, which makes our decimal look like it's moving 5 places to the left. 1, 2, 3, 4, 5. So my final answer is 3 and 33,788 100,000ths. Now, I suspect that they're going to round that off, and if we look at the answer choices, yes, they did round that to the nearest thousandth. Here is your thousandths place right here. The 8 to the right of it, this one right to the right of it, is going to tell that one to bump up. So it's going to be 3 and 338 thousandths of a gram. And question 4 is the same, exactly the same type of problem as the previous one, but we have different numbers. So in this case, their alloy that they're working with only contains 667 thousandths of a gram of gold, and we want 5.55 grams of that. This one does tell us to round to the nearest thousandth. So just like before, we're going to take our 667 thousandths, multiply it by the 5.55. And before we begin, we're going to count how many place values we're going to need to shift the decimal when we're done. 1, 2, 3, 4, 5. I'm going to write that out to the side to remind myself 5 place values. And now my problem becomes 667 times 555. And it's just a regular whole number multiplication problem. So that's 33. 5 times 7 is 35. 33, and then 33 again. Remember to put 2 zeros here. 5 times 7 is 35. And I'll carry the 3. 6 times 5 is 30, plus 3 is 33. Carry the 3 again. And then 6 times 5 is 30, plus 3 is 33. This is where your problem gets a little bit messy, so you just really need to make sure you're really careful with writing down your numbers. So it looks like our digits are going to be 370185. However, we're going to shift those 5 place values to the right, which makes it look like our decimal will move 5 place values to the left. 1, 2, 3, 4, 5. So then we have 3 and 70,185 100,000ths. However, the problem does tell us to round to the nearest thousandth. This is the thousandths place, and the digit to the right is the 10,000ths place. And there are more than 5 10,000ths there, so we're going to round this up to the next thousandth, so it'll be 3 and 702 thousandths grams.